Welcome to the lecture on retrosynthetic analysis. Retrosynthesis is a process of deconstructing or disconnecting a target molecule into readily available starting materials by means of imaginary breaking of bonds, imaginary disconnection of bonds, and by the conversion of one functional group into another functional group, which we call as functional group interconversion. Retrosynthesis is a technique of working backward from the target molecule to easily available starting materials. The art of planning the synthesis of a target molecule by working backward, which means working backward from product to reactant, is called retrosynthetic analysis. The target molecule is transformed into simple precursor structures. This is a technique for solving problems in the planning of organic synthesis. Retrosynthesis is useful for finding different synthetic routes for the same target molecule, and this retrosynthetic approach was formulated by E.J. Corey. Retrosynthetic planning goes from product to the starting materials. A good retrosynthetic planning should be able to give highest yield with the lowest number of steps and with the easily available starting materials. So usually we look for what will be the product when X and Y react. That is the synthetic reaction. In a retrosynthetic reaction, we look for the reactants to generate a particular product. We look for X and Y to make Z. Here I have given a retrosynthetic reaction where Z is the target molecule and these X and Y are the starting materials used for preparing the target molecule Z. So the retrosynthetic reactions are represented with the open arrow. This is called a retrosynthetic arrow. A synthetic chemical reaction can be viewed in two directions. One is synthetic direction, the other one is the retrosynthetic direction. In synthetic direction, we go from reactants to the product, the target molecule. And in retrosynthetic reaction, we go from product to the reactants, from target molecule to the starting materials. Let us learn some important terminologies used in retrosynthetic analysis. Target molecule, this is the product you want to make from the available starting materials. Retro reaction or transform, it is the reverse of the synthetic reaction in which we look for the immediate synthetic precursor for the target molecule, and this is a purely hypothetical process. And in retrosynthetic analysis we are using a special type of arrow. This shows it is the retrosynthetic reaction and we go for in the backward direction from product to starting materials or precursors. The word synthon or retron is the idealized fragment, usually an ion, resulting by disconnection of a bond in the target molecule. So here I have given an alcohol, and when we write the retro reaction, we break this carbon hydrogen bond and generate a carbocation and hydride anion. These are called synthons or retrons. The fragments obtained by disconnection of the target molecule are called synthons, and the commercially available synthetic equivalent or molecular form of these synthons are called synthetic equivalent. The word disconnection refers to a retrosynthetic step involving the breaking of a bond in the target molecule to form two or more synthons. So, disconnection is an imaginary disconnection, a hypothetical disconnection of a bond in the target molecule to get as many synthons possible. The word functional group interconversions, FGI, means changing of functional group, which includes functional group addition, removal, and interchange. Here is an example for retrosynthetic reaction. I have given a molecule benzyl benzoate. It is used to treat scabies and lice. This target molecule we are disconnecting here. Always you remember, when there is a carbon chain containing a heteroatom, we can do the disconnection next to the heteroatom. So in this molecule I have shown the disconnection. So the disconnection you can show with this symbol or with a zigzag line like this. So we do a disconnection here and we put minus on oxygen, plus on carbonyl, because electronegative atom oxygen can take up negative charge, so that these are logical synthons. Reasonably stable synthons are called logical synthons. So these are the synthons for this target molecule, and we look for the synthetic equivalents for these synthons. If you add H plus with this, you get benzyl alcohol. Here we have a carbocation, and with this carbocation you can add a nucleophile, an anion, a good leaving group, chloride. So these are the synthetic equivalents of the synthons. Now you can prepare this target molecule benzyl benzoate and ester from these two molecules, alcohol and acyl halide. So this is an example for retrosynthetic analysis, and you can try to write retrosynthetic reaction for as many reaction target molecules as possible. Thank you.